Hi, I'm Athira, and today we're going to be talking about quadratic inequalities. So hopefully by the end of this video, you'll know how to graph quadratic inequalities in two variables and solve quadratic inequalities in one variable. So let's start with quadratic inequalities in two variables. So the first thing that we're going to talk about is graphing these quadratic inequalities in two variables. A quadratic inequality in two variables can take one of these forms. You can have y is less than ax squared plus bx plus c, where ax squared plus bx plus c is just the standard form of a quadratic. You can have y is greater than ax squared plus bx plus c. You can have y is less than or equal to ax squared plus bx plus c. And you can have y is greater than or equal to ax squared plus bx plus c. And each of these inequalities is going to represent a region on a coordinate plane that includes all of the solutions of the inequality. So the steps to graph a quadratic inequality is as follows. So the first step is you're going to graph the parabola y equals ax squared plus bx plus c. And you're going to make the parabola dashed if the inequality is less than or equal to, or is less than or greater than. And you're going to make it solid if it's less than or equal to or greater than or equal to. The second thing that you're going to do after you've graphed the parabola is you're going to pick a point inside the parabola and then you're going to substitute its coordinates into the inequality to see if it satisfies the condition. So you're going to pick a point inside the parabola, substitute, and then see if it satisfies the condition. If the point that you picked inside the parabola satisfies the inequality, you're going to shade the region inside the parabola. And if it doesn't, you're going to shade the region outside the parabola. So if point satisfies inequality, shade inside the parabola. If not, shade the region outside the parabola. So let's take an example. Let's say we have y is less than negative x squared minus 2x minus 1. The first thing that you're going to do is you're going to graph negative x squared minus 2x minus 1. So let's go ahead and graph that. So the first thing that I see is that we're going to have a y-intercept at 0, negative 1, right? If you plug in 0 for x, you'll get y as negative 1. So that's one point that we can plot already. The next thing that I can do is I can figure out the zeros of this equation. So if you have negative x squared, if I can factor out a negative, I can take out a negative, and then inside the parentheses would be x squared plus 2x plus 1. And that is actually a perfect square. That's negative x plus 1 squared. Now I know my root, my x-intercept, is going to be at negative 1, 0. So that's another point I can plot. And now I know my axis of symmetry is going to be here, along this line, which means I can plot my next point, which will be at negative 2, 1. And then you have a parabola that kind of looks like this. Now, the inequality is less than. It's not less than or equal to, so when I draw the parabola, I should use a dashed line instead of a solid line. So let's go ahead and do that. It should look like that. That's your dashed line. Now the second thing that we're going to do is we're going to test a point inside the parabola. So let's choose 0, -3. That's inside the parabola, right? This would be 0, -3, and you can pick any point that you want. 0, -3 is just a point that's inside the parabola. So let's see what happens when I substitute that point back into the inequality. So you would have your y value, which is -3, is less than -0 squared minus 2 times 0 minus 1. And you get -3 is less than -1. And that's true. -3 is less than -1. And so I would shade inside the parabola. So right here is where I would shade. Okay, so let's take another example. Let's say we have y is greater than or equal to x squared plus 3x plus 2. So the first thing that we're going to do is we're going to start by graphing this. I can see that the y-intercept is going to be at 0, 2, because the y-intercept is always just this c term here. And that I can double check by plugging in 0 for x. When I plug in 0 for x, I'll get 2 for y. So we're going to have the y-intercept at 0, 2. The next thing I can do is I can find the roots of the quadratic function by factoring. So if I factor x squared plus 3x plus 2, I'll get x plus 2 times x plus 1. So the factored form would be x plus 2 times x plus 1. So from here I can figure out the roots are going to be x equals -2 and x equals -1. So I have a root at -1, 0 and -2, 0. And now I know that the vertex is going to be in between, smack in the middle between -1 and -2. So the x-coordinate for the vertex will be at -1.5. And in order to find the y-coordinate, I can plug it into this equation, x squared plus 3x plus 2. And so if I do that, I'll get -1.5 squared plus 3 times -1.5 plus 2. Now, 1.5 squared is just 2.25 plus 3 times -1.5 is -4.5, so it's going to be -4.5 plus 2. So we have 2.25 minus 4.5 plus 2 is going to be -0.25. So the vertex is going to be at -1.5, comma, -0.25. So it should be somewhere there, roughly. And now I can just graph that, or plot that point, and I can kind of see the rough shape of the parabola. And since its y is greater than or equal to, the line is going to be solid. The next thing that I can do is I can graph, or I can pick a point inside the parabola and then substitute that in to figure out if it satisfies the inequality. So let's test the point 0, 3, which is like right here, which is inside the parabola. So if we pick the point 0, 3, we'll have 3 is greater than or equal to 0 squared plus 3 times 0 plus 2. And 3 is greater than or equal to 2, which means that we shade inside the parabola since 3 is greater than or equal to 2, and that means it satisfies that condition. So we can shade inside this parabola here. Okay, so the next thing that we're going to go over is we're going to go over graphing systems of quadratic inequalities. And so this involves graphing two or more inequalities on the same coordinate plane and shading the area where all of the regions overlap. So so the process is the same, so let's try an example. So let's say we have a system of quadratic inequalities where we have y is less than negative x squared plus 3, and y is greater than or equal to x squared plus 2x minus 3. So the first thing that we're going to do is we're going to graph both of these. So let's see. For negative x squared plus 3, I know that there is a y-intercept at 0, 3. And I also know that the parabola is downwards facing. And so we can see that when x is 1, for example, y is going to be equal to 2. And when x is negative 1, y is also going to be equal to 2. Similarly, if x is 2, y is going to be equal to negative 1, and when y is negative 2, y is also going to be equal to negative 1. When x is negative 2, y will be equal to negative 1. And so now I can kind of see the shape of this parabola. And we're going to use a dashed line because it's y is less than and not y is less than or equals to. So that's the graph of one parabola. For the second parabola, we're going to follow kind of the same process for graphing. So I know that there's a y-intercept at negative 3. So that's going to be one right there. I also know that I can find the roots of this by factoring. So if I factor x squared plus 2x minus 3, I will get x minus 1 times x plus 3. And so my roots are going to be at positive 1, negative 3, which should be around here. And for my vertex, I know that the vertex is going to be at negative 1 here. The x-coordinate of the vertex is going to be at negative 1. And if the x-coordinate of the vertex is negative 1, I can find the y value by plugging negative 1 in for x. So I'll have negative 1 minus 1 times negative 1 plus 3. Negative 1 minus 1 is negative 2. And negative 1 plus 3 is just 2, which means that I have a y value for my vertex at negative 4. So my vertex should be right there. And using the axis of symmetry, I can see that that's also going to be a point on my parabola. So this is going to be your other parabola. And now I'm going to pick a point inside both of these parabolas. Let's plug in 0, 0 for both of them. So let's say we'll have 0 is less than negative 0 squared plus 3. So 0 is less than 3, which is true. And then we'll also have 0 is greater than or equal to 0 squared plus 2 times 0 minus 3. And so 0 is greater than or equal to negative 3, which is true, which means you're going to shade inside this region right here. The next thing that we're going to talk about is solving quadratic inequalities in one variable. And so these inequalities, you can use algebra and graphs to identify solutions. So the way that you can solve quadratic inequalities algebraically is the first thing that you're going to do is replace the inequality symbol with an equal sign and solve the equation for its roots. So the first thing that you're going to do, replace And once you find the roots, you can plot these critical values on a number line. And what that's going to do is it's going to divide the number line into intervals, and then you're going to test a point in each interval to see if it satisfies the inequality. So you're going to plot critical values on a number line, and then test a point in each interval. Okay, so let's take an example. Let's say we have, we want to solve x squared minus 3x minus 4 is less than 0, and we want to solve that algebraically. So the first thing that we're going to do is we're going to replace this inequality symbol with an equals. So the first step is going to be x squared minus 3x minus 4 equals 0. Now we can factor this in order to find its roots. To factor it, you want to find two numbers that multiply into -4 and add to -3. So that would be x minus 4 times x plus 1. -4 times 1 is -4, and -4 plus 1 is -3. And so the roots of this quadratic function is going to be x equals 4 and x equals -1. Now you can plot this on a number line. So we have -1 here, and 4 here. And now we're going to take a point in each interval. So we're going to separate it by the critical values. So this is from -2, or from, there's going to be x less than -1 here, and there's going to be x between -1 and 4, and there's going to be x greater than 4 here. So let's take a number in the interval x less than -1. So we just want to pick a number that's less than -1. So let's choose -2. And now we're trying to see that when we plug in -2, is this portion actually less than 0? So let's see. Let's plug in -2. We'll have -2 squared minus 3 times -2 minus 4. That's going to be equal to 4 plus 6 minus 4, which equals 6. Now 6 is not less than 0, and so we know that this interval can't be the solution. So let's try a number between -1 and 4 for this interval. Let's just try 0. So let's see what happens when we plug in 0 for this. We'll have 0 squared minus 3 times 0 minus 4, which is just equal to -4. And -4 is actually less than 0, which means that this interval is a solution. And lastly, let's try for any number greater than 4 for x. So let's try 5. If we plug in 5, we'll get 5 squared minus 3 times 5 minus 4 is equal to 25 minus 15 minus 4, which is just 6, which is also not less than 0. And so this is not a solution. This interval is not a solution. So that means the solution is just -1 less than x, which is less than 4. That would be your solution. Okay, let's try another example. Let's say we have this inequality. We have 2x squared plus 3x is less than or equal to 2. Now we can rewrite this. If we subtract 2 from each side, we can rewrite this as 2x squared plus 3x minus 2 is less than or equal to 0. And now we can replace the symbol with an equal sign. So now we have 2x squared plus 3x minus 2 equals 0. And we can factor this. So if we factor this, we'll have a 2x here and an x here. And this would be plus 2, and this would be minus 1. Because negative 1 times 2 is going to be negative 2, and then negative x plus 4x, negative 1x plus 4x here is going to be 3x. So that's how I know these are the roots. So we'll have x equals 1/2 for one of the roots, and x equals negative 2 for the other root. So now we can plot this on a number line. So negative 2 is going to be one of your roots, and this other dotted line I drew is at x equals 1/2. And so we're looking at these 3 intervals. We're looking at for x less than negative 2, for an x between 1/2 and negative 2, and we're also looking at this interval which is x greater than 1/2. So let's try out a value for this interval here, x less than negative 2. So let's choose, let's say negative 3. And I'm going to plug it into the factored form here because it's just a little easier to do the math. But we can do 2 times negative 3 minus 1 times negative 3 plus 2. And you would get negative 7 times negative 1, which is going to be 7. And 7 is not less than or equal to 0, because we're testing whether it's less than or equal to 0. 7 is not less than or equal to 0, and so this is not a solution. The next thing that we're going to test is we're going to test in the interval of x between negative 2 and 1/2. So let's just choose 0. 0 is in between negative 2 and 1/2. So if we choose 0, we'll get 2 times 0 minus 1 times 0 plus 2. 2 times 0 minus 1 is negative 1. And then times 2 is going to be negative 2. And negative 2 is less than or equal to 0. That's true, which means that this is a solution to our inequality. The last thing that we're going to do is we're going to test a point in this last interval where x is greater than 1/2. So let's test out 1. If we test out 1, we'll get 2 times 1 minus 1 times 1 plus 2. 2 times 1 minus 1 is just 1. And 1 plus 2 is 3, so we'll have 3. 3 is not less than or equal to 0. And so this is also not a solution here, this interval. And so your solution is going to be negative 2 less than x less than 1/2. That's going to be your solution for this.